Photovoltaic energy is a conversion of sunlight into electricity through a photovoltaic cell, which commonly call it solar cell. A photovoltaic cell is a non-mechanical device, usually made from the silicon alloys. When photons strike a photovoltaic cell, they may be reflected, pass right through, or be absorbed. The absorbed photons provide the energy to generate electricity. When enough sunlight is absorbed by the material, which is a semiconductor, electrons are dislodged from the material atom and produce the current. When the electrons leave their position, so-called holes are formed. When many electrons, each carrying a negative charge, travel toward the front surface of the cell, the surface imbalance of the charge between the cell's front and back surfaces creates a voltage potential like the negative and positive terminals of a battery. The PV cell was discovered in 1954 by Bell Telephone researchers examining the sensitivity of a properly prepared silicon wafer to sunlight. Beginning in the late 1950s, PVs were used to power US space satellite, and now is finding its way into our homes. This is the use of the PV in transportation systems. The three pictures here: a solar car, a solar plane, a solar boat. They're all powered by the power only from the sun. There are different types of solar cells depending on the material that is used and the impurities in the materials. We can use this thin film solar cells and small cells, which are called microcells, the concentrated cells, and also the spherical cells. The material can be monocrystalline, polycrystalline, amorphous silicon. The price of solar cells is dropping very rapidly, and very soon it will reach the price that can compete effectively with the non-renewable forms of energies. This is a Fresnel lens. Again, as we discussed, that's one way to concentrate the sunlight. So by concentrating sunlight on a solar cells, we can increase the efficiency. This is multi-junction solar cells. It was developed by the Sandia Lab, and it's basically made of several wafers, and each of these wafers is sensitive to one frequency of the light. So the light shines on these wafers, they penetrate the first wafer surface, and the low energy, which is in the reddish region, it will be absorbed, generating some electricity. The remain will hit the second layer, and additional electricity is generated. And as we go through the different layers, then we can take advantage of the full spectrum of the visible sunlight to produce electricity, thus increasing the efficiency quite a bit. Spherical solar cells, the p-n junction is in the spherical form. Basically, there is two layers. There is one sphere, which is a p-type spherical silicon crystal, only about 1/2 to 2 millimeter in diameter, and very thin layer of material is being sprayed on it and is covered by the surface of the anti-reflection film. The advantage of this is that these cells are independent of the direction of the sunlight. No matter which direction the sun comes in, it will be concentrated, and so the efficiency is higher. Furthermore, the thickness is very small, and so the cell can be manufactured in any form, and they're very flexible. This is done by a Japanese company. Always we can concentrate the sunlight to increase the efficiency. In this case, we use the Fresnel lens to concentrate the sunlight. This diagram shows the solar power satellite. Solar power satellites, the concept is we take these solar cells into the outer space, the diagram at the left, and then directly face it toward the sun. The electricity generated can be turned into the microwaves and beamed toward the ground. On the ground, this microwave is collected and converted back to electricity and sent to the house. The idea had been around since 1980s. It still is viable. The cost is very high though. And the amount of the material that has to be sent out to the outer space is quite heavy. So we're waiting for more efficient way of hauling the material to the outer space to construct this kind of power station. This one is solar cell. The Japanese call it Icarus, after the mythical story of Icarus that flew close to the sun, burned, and fell back to earth. This is a very thin layer of mylar. When the sun shines on it, sun can exert a pressure. Light has a pressure just like a liquid. So when the sun hits this thin mylar, then it will push it and accelerate it in the direction of sun incident. This is the possible scenario if you want to travel in the interstellar distances for very long distances. The reason is that because there's no air, the sail can be accelerating and moving at higher and higher speed, way beyond the sonic speed. So there's no limit into the speed that can travel. The NASA has abandoned the research in the solar cell propulsion, but Japan's JAXA successfully tested Icarus in 2010. The goal was to deploy and control the sail, and for the first time determining the minute orbit perturbations caused by the sun pressure. Thermophotovoltaic is like solar photovoltaic, except that solar photovoltaic works in the visible wavelengths as thermophotovoltaic works in the infrared frequencies. In the thermophotovoltaic, we can use the heat from the boilers or flames to produce electricity. The efficiency is governed by because it's a thermal system governed by the Carnot efficiency, which is 1 minus temperature of the cell over the temperature of the emitter. The application is in the space travel, recreational vehicles can be used, and every place that there are some waste heat. Also, there are people that trying to use this application to use the heat of the body or the sun to produce the portable power source for the soldiers or to charge the laptop and cell phones. This is one way to produce a hybrid system. This is called high gain solar system developed by Skyline Solar in Northern California, basically using the combination of traditional photovoltaic and long reflecting trough surfaces. Array of low cost reflective surface which are silver coated glass mirrors concentrate the light onto narrow bands of conventional photovoltaic cells and produce electricity. Because it can be built in a small modular building block, this kind of hybrid system can be used in plants ranging from a very small hundreds of kilowatts to many megawatts. Thank you.